Welcome to the Deep Dive, the show where we cut through the noise and deliver the crucial insights you need to be truly well-informed.
Glad to be diving in today.
Today, we're plunging into a topic that's not just rapidly evolving, but fundamentally reshaping how organizations function. The explosive growth, the adoption of generative AI, retrieval-augmented generation, or RAG models, and especially these incredibly powerful new agentic systems. You're seeing them emerge everywhere, really, across industries, automating complex workflows, delivering highly personalized digital experiences.
Yeah, it's more than just, a technological advancement. It feels like a real paradigm shift in how we build and interact with software. These AI agents aren't just performing tasks anymore.
Right.
They're capable of multi-step reasoning, making dynamic decisions, orchestrating complex actions. They're becoming, well, almost like digital collaborators.
Digital collaborators, I like that.
And that brings with it a fascinating new set of challenges we absolutely need to get our heads around.
And that's precisely our focus for this deep dive. The core issue we're tackling today is, well, it sounds simple, but it's incredibly complex in practice.
Deceptively simple.
Exactly. With these dynamic, often multi-step AI processes, where multiple agents are handing off tasks, how do we reliably and securely propagate a user's identity, who they are, and their privileges, what they're allowed to do, across that entire agentic flow?
It's a critical question.
It's all about ensuring that who is ultimately responsible for what remains crystal clear, auditable, and, crucially, protected. Protected from misuse, unauthorized access, all of that.
Right. Think of it like a digital passport and maybe a stack of permission slips. In let's say, the traditional world, you might share your passport once, maybe twice.
Right.
But in this agentic world, that passport and those permissions, they need to be continuously validated, re-stamped almost as you move through this intricate multi-stop journey, often with different, guides or agents.
So how do we keep that chain of trust unbroken and accountable?
That's the million-dollar question.
So our mission in this deep dive is to extract the most important, maybe sometimes surprising, insights from the expert discussions happening right now on the evolution of identity propagation.
Specifically for these new AI systems.
Specifically for these systems, we want to give you a genuine shortcut, a way to get well-informed on this vital emerging field. We'll uncover not just the problems, but also the practical, cutting-edge strategies being developed.
Sounds good. Let's get into it.
Okay, let's unpack this. To really grasp the complexities and the innovative solutions in this world of AI agents, we first need to lay a bit of groundwork, a foundational understanding of what identity propagation actually is.
Right. Back to basics for a moment.
You mentioned the digital passport and permission slip idea. It's about maintaining that continuity of identity as a user moves through different parts of a digital system, right?
That's right. At its most basic level, identity propagation is, it's about how a user's identity, their unique digital fingerprint, you could say, their verified persona, and their specific permissions or rights travel with them.
As they interact.
As they interact across different applications, different services within a digital system, it's the underlying mechanism, really, that ensures if you, as a user, are logged in and you're authorized to access specific files or perform certain actions, that authorization seamlessly follows you. Even if your request gets processed by several different software components or hops behind the scenes.
So it's not just about getting access to that first door, but making sure your key works for all the subsequent doors your request needs to go through within that system.
Exactly. Your access permissions follow you.
Why is this foundational concept so critically important? I mean, it sounds a bit like technical plumbing, but you're saying it has huge implications for security and trust.
Oh, it's absolutely foundational. Its importance, honestly, cannot be overstated. For security, for access control, for robust auditing in any digital environment. Think about it. Without solid identity propagation, you'd either have a situation where every single component in a long chain of services needs to re-authenticate you, which is just wildly inefficient.
Nightmare for the user.
Totally. Or even worse, they might operate without any knowledge of who you are. And that leads to gaping security holes, a complete lack of accountability.
Right. You wouldn't know who did what.
Precisely. If a sensitive customer record is accessed, for instance, you need an unbroken, verifiable trail. You need to prove who accessed what and when they accessed it. This isn't just about security either.
What else?
It's about compliance, legal accountability, and fundamentally building user trust. People won't use systems they don't trust, handle their identity correctly. It's the bedrock. All secure digital interactions are built on it.
That makes perfect sense. It's like ensuring every step of a complex delivery is tracked and signed for. Okay, so before we leap into the brave new world, maybe the slightly wild world of AI agents, let's look back briefly at how identity has historically been managed. These traditional delegation patterns, they're like the building blocks, right?
They absolutely are.
And understanding their strengths, but maybe more importantly, their limitations, helps us really appreciate why the new challenges with AI are so, well, profound. Let's start with the simplest one you mentioned. No delegation.
Right, no delegation. In this model, it's very straightforward. And frankly, kind of antiquated for many modern applications. You've got a user interacting directly with an application, maybe a simple web app, a static website.
Right.
That application then independently connects to some back-end system. Could be a database, a file server, an internal service, whatever it needs to talk to.
So how does that actually work behind the scenes? Who knows what in this scenario?
So the key here is that the back-end system, let's say our database, it has its own secure connection, but that connection is established directly and solely with the application itself.
Not the user.
Not the user. The database trusts the application implicitly. But crucially, it doesn't know, and it doesn't need to know, anything at all about the original user who kicked off the request.
Really? It's completely blind to the user.
Completely blind. The database just provides the requested info back to the application, which then relays it to the user. From the backend's point of view, it's always the application making the request, never a specific user. There's no user identity passed along, hence no delegation of that identity.
That sounds incredibly simple, which, as you said, makes me think it must be highly limited for anything beyond the most basic interactions.
Yeah.
What are the implications today?
You're spot on. It's straightforward, but the limitations are severe, especially if you need things like user-specific privileges or personalized experiences or, detailed audit trails.
Which most systems do need now.
Exactly. Imagine like an old public library catalog terminal. You walk up, type in a book title, the terminal retrieves if it's available. The database behind it doesn't log who you are. It just knows the terminal asked.
Right. Anonymous access.
Anonymous. But if you needed to actually check out that book, or if the library had special privileges, maybe students versus faculty needing access to restricted journals, this model just falls apart. It's only really suitable for anonymous, undifferentiated access.
Or where the application itself does all the heavy lifting for user logic.
Right, which just pushes a lot of complexity onto that application layer.
Okay, so that's no delegation. Very limited.
Yeah.
Now, let's take a crucial step forward towards, true identity propagation with something called trusted assertion. This sounds like one system is vouching for your identity to another.
Precisely. With trusted assertion, we introduce a critical and very widely adopted component, the identity provider, or IDP.
The IDP. Okay.
This is a dedicated, highly secure service. Its whole job is just to authenticate users. So the user first authenticates directly with this IDP. Proves who they are, username, password, maybe multi-factor authentication. That's your initial digital passport check.
Got it. And then what happens? How does that verified identity information actually get used by the applications the user wants to access?
Okay, so once the user is successfully authenticated by the IDP, the application they want to use, and this is key, has already established a prior, usually cryptographic trust relationship with that IDP.
So they trust each other.
They trust each other. The application then receives an assertion about the user from the IDP. You can think of this assertion like a sealed, tamper-proof envelope. Inside is a statement, digitally signed by the identity provider, vouching for your identity. It might also include some basic attributes like your department, maybe your role, your email address. A very common format for this is SAML assertion.
SAML, right. Heard of that.
Yeah, it's an XML-based standard designed specifically for securely exchanging authentication and authorization data. So the application gets this envelope, it verifies the IDP's digital signature to make sure it hasn't been tampered with.
Checks the seal.
Checks the seal. And then it trusts the information inside. It then uses this assertion to inform the backend system, the database or whatever service, who the original user is.
So now the backend knows the user.
Exactly. This allows the database or backend service to check specific privileges for that individual user, not just the application itself. So if user A is only allowed to see certain types of data, the database can actually enforce that policy based on the trusted assertion it received via the application.
That feels like a huge leap from no delegation, because now the backend system actually knows who's making the request, not just which application is asking. Sounds like this enables personalization, tighter security.
It absolutely does. This is a really crucial step towards true identity propagation. It enables personalized access, much more fine-grained privilege checking, and way more granular auditing. We move beyond an application is asking for data to user X through this application is asking for data, and user X has these specific rights.
It's foundational for things like single sign-on, right? SSO.
Exactly. It's foundational for the SSO experiences we all use every day. You log in once, gain access to multiple linked applications without having to re-authenticate each time.
Makes sense.
But there's still a potential limitation. That assertion is often consumed by the immediate application. Passing it further down a complex chain of services, well, that can become cumbersome or maybe less secure if it's not managed very carefully.
Okay, so building on that foundation, we get to simple delegation. This introduces a concept we're probably all familiar with from just using the internet, the token. This seems to be the go-to method in a lot of modern web services.
You're right, it really is. Simple delegation takes that concept of trusted assertion and evolves it by introducing the idea of a token. So, after authenticating with the identity provider, the user doesn't just trigger an assertion sent to the application. Instead, the user receives a token directly from the IDP.
The user gets the token.
Well, their browser or client app does.
Yeah.
This token is essentially a portable, usually time-limited credential. It represents the user's authenticated identity and their allowed privileges for that specific session.
And these are often JWTs, right? JSON Web Tokens.
Very often, yes. A JWT is a widely used standard for these tokens. It's compact, it's URL safe, which is handy, and it's a way of representing claims statements about the user to be transferred between parties. And critically, it's digitally signed.
Signed how?
Often with a secret key shared between the IDP and the recipient, or using a public-private key pair. That signature ensures its authenticity and integrity. You know it came from the IDP and hasn't been messed with.
Okay, so the user's browser has this signed JWT, this token. How does it then get used to communicate with back-end systems? And what's the main advantage over just getting a direct assertion sent to the app?
Right. So the user, or really their browser or client application, passes this token along with its requests. Usually in an HTTP header, like an authorization header, it sends it to the application it wants to interact with.
Okay.
The application, in turn, takes this token and uses it when communicating with subsequent backend systems, our database, other APIs, microservices, you name it.
And the backend can check it.
Yeah. The backend service, because it also has a trust relationship with the IDP, it knows the IDP's signing key, can then verify the token's signature, confirm it hasn't expired, check it's valid, and then grant access or perform actions based on the identity and privileges embedded within that token. The token essentially becomes the representation of the user's identity and their allowed privileges for that session, like a temporary, digitally signed VIP pass.
And the advantage is flexibility.
Flexibility and scalability, yeah. Tokens can be revoked if a session needs ending early. They usually expire after a short period, which limits risk. And crucially, they can be scoped for very specific purposes, which we'll definitely talk more about later. It decouples the initial, maybe heavier authentication process from all the subsequent lighter authorization decisions made by different services.
Right, you don't have to re-authenticate constantly.
Exactly. It allows for a much more distributed and scalable approach to managing user sessions across potentially many different services, which is absolutely vital in modern microservices architectures.
Okay, so let's quickly recap this foundational bit. We've journeyed from no delegation, backend is blind to the user, to trusted assertion. App vouches for the user via a signed statement to simple delegation. A portable verifiable token, like a JWT, represents the user's identity and privileges. And these patterns primarily address how identity is propagated and what a user is allowed to do, but mostly within, let's say, relatively static, well-defined system architectures.
That's a good summary. They work well when the path is predictable.
But now we dive deeper. because we're confronting a whole new ballgame where these established patterns start to show some, well, some significant cracks.
Indeed. The landscape just fundamentally changes with generative AI, RG models, and especially these complex agentic systems. We're not talking about a simple user app database flow anymore, or even just straightforward API calls between known services.
It's messier.
It's much more dynamic. These systems involve multiple intelligent AI agents interacting, often in sequence, sometimes making their own decisions about where to go next. They orchestrate actions autonomously. You end up with these multi-node, multi-hop interaction chains.
Okay.
And they're far more intricate, often less predictable, and much more fluid than the systems we've traditionally built identity solutions for. It's like going from planning a direct train route to navigating a complex network of interconnected, maybe even self-driving
Taxis, self-driving taxis making their own route decisions.
Yeah.
Yeah, you can almost picture the complexity, can't you? It's not just one hop, but potentially a whole series of handoffs between different AI brains.
Exactly.
Do you walk us through maybe a typical simplified agentic flow, just so we can really visualize this progression of identity and where things might go wrong?
Sure, let's try a simple one. Imagine a user starts interacting with an initial AI-powered chatbot. Let's call it Agent 1. Maybe it's a customer service bot on a website. The user authenticates once, right at the start, with an identity provider. Agent 1 gets a token representing that user's identity and their initial permissions. Now, based on what the user asks, the user asks about their financial portfolio details.
Sensitive stuff.
Sensitive stuff. Agent 1 might decide, okay, I can't handle this directly, I need to route this request. So it sends it to a specialized financial query agent. Let's call it Agent 2.
Right.
Agent 2 looks at the request and maybe determines it needs very specific data from a secure backend system. So it might consult another agent, Agent 3, which specializes in securely retrieving data from, say, a core financial database.
So you've got a chain already.
You've got a chain. User authenticated, Agent 1, Agent 2, Agent 3, backend system. And the critical challenge then becomes, how is that initial identity and the privileges tied to it propagated and crucially maintained with integrity across all those subsequent dynamic AI-driven hops?
Yeah, because Agent 2 and Agent 3 need to know who they're working for.
Exactly. Each agent needs to know not just what to do, but for whom it's doing it and with what authority. That's where things get tricky.
And that's where the new challenges really start to bite, because this isn't necessarily a pre-programmed static flow. Let's talk about what feels like the most immediate, maybe visceral threat: the peril of impersonation by bad actors. This sounds like a hacker's dream scenario in these complex flows.
It absolutely is, and it's a profoundly difficult problem to solve completely. The new challenge here is this. If an identity, maybe represented by that token, is simply passed along this dynamic, potentially unpredictable chain of AI agents, how can the downstream agents, Agent 2 or Agent 3, truly verify its legitimacy?
Because they didn't see the original login.
Exactly. It's not just about an application handing a token to a database it knows and trusts. It's about a series of intelligent agents, maybe making choices about the next step in the flow. And that just opens up entirely new vectors for attack. The dynamism itself creates uncertainty that wasn't there before.
So give us a concrete scenario. How could this vulnerability actually play out? Make it real for us.
Okay, consider this scenario, pulled from some expert discussions. A sophisticated bad actor, someone with malicious intent, could potentially create their own rogue AI agent or system.
A fake agent.
A fake agent. This malicious agent could then try to cleverly insert itself into the agentic flow. Maybe it exploits a misconfiguration somewhere or finds a way to mimic a legitimate agent, perhaps connecting directly to an internal router or an API endpoint it really shouldn't have access to. It pretends to be a legitimate part of the chain.
Slides itself in.
Slides itself in. Once it's inside, this rogue agent could then inject a false identity. The source material uses this really striking, kind of evocative example: Edwina Cutwater impersonating Roger Cobb.
Okay, so Edwina is the bad actor's agent, pretending to be Roger, who maybe has high privileges.
Yeah. Exactly. Edwina, the rogue agent, claims to be Roger Cobb, maybe a system admin or someone with access to lots of sensitive data. This rogue agent would then attempt to gain all the privileges of the impersonated user, Roger, accessing data, initiating unauthorized transactions, executing actions they absolutely shouldn't be able to.
And the really scary part.
The really insidious part is, in a long chain, it's like that old game of telephone. An agent deep in the flow, say Agent 3, might just blindly accept the identity passed to it from the rogue agent, posing as Agent 2 perhaps, completely unaware of the malicious insertion that happened much earlier in the chain.
That's genuinely chilling to think about. And the reason this is so difficult to counter is because of that lack of direct visibility back to the start, right? It's not just the token, it's the chain of trust itself that's potentially broken.
Precisely. That is the absolute crux of the problem. Agents further down the flow, Agent 3 in our example, they have no direct connection, no visibility back to where the user originally authenticated with the IDP, way back with Agent 1.
They just get what's handed to them.
They just receive an identity that claims to be legitimate, coming from what appears to be the preceding trusted agent in the chain. This makes independent verification extremely difficult. If Agent 3 gets an identity claim, it has no inherent way of knowing for sure if that came legitimately from Agent 2, which got it from Agent 1, which properly authenticated the real user, or if it was injected by an imposter, like Edwina, at an earlier unauthorized hop. The integrity of the entire chain relies on this implicit trust between sequential hops, which, frankly, is a massive security gap in dynamic systems. One expert I talked to recently described it almost like a blindly trusting a whisper network.
Wow. And the consequence of this kind of impersonation succeeding sounds catastrophic, not just for data, but for the organization's credibility.
It truly is. This represents a massive security vulnerability. It could potentially lead to widespread unauthorized access to sensitive data, confidential information, critical system functions. If an imposter can successfully inject a false identity with high privileges, pretty much, they could compromise entire systems, leading to devastating data breaches, crippling operational disruptions, severe financial loss, and huge reputational damage. It just highlights the urgent need for a much more robust, continuous approach to identity verification in these dynamic, multi-hop environments, especially where human oversight is minimal or non-existent. It's a fundamental challenge to building secure autonomous systems people can actually trust.
So, building on that specific thread of impersonation, there's a related, maybe deeper, more pervasive problem. How does any agent within one of these complex, multi-hop agentic flows truly trust the identity it receives? Even if it wasn't maliciously injected, how does it know it's still valid and correct given the journey it took?
This really is the core issue of trust in these new architectures. Think of it this way. An agent deep in the flow, let's stick with Agent 3 in our example, it has no direct connection or visibility back to the user's original authentication point. That happened way back with the IDP in Agent 1.
Right. It's far removed.
It's far removed. It relies entirely on the preceding hops, Agent 2 and Agent 1 in this case, to have correctly validated and propagated that identity. But what if one of those intermediate agents was compromised? Or maybe not compromised, but just buggy. Or what if the flow itself deviates unexpectedly from the normal path because of the AI's dynamic routing?
Then the identity information could be wrong.
It could be tainted or maybe just outdated or associated with the wrong context. There's often no inherent mechanism for a downstream agent like Agent 3 to independently verify the provenance of that identity, where it really came from and the path it took to get there. It's just accepting the word of the agent immediately before it.
And what are the stakes when that trust is broken or maybe just can't be established definitively? You said it goes beyond just security.
The stakes are incredibly high. And you're right, it extends beyond just security. It impacts the fundamental reliability and accountability of the entire system. This raises the basic question: how do we ensure the identity being carried through the system is genuinely the correct one? And, equally important, how do we guarantee that sensitive data or privileges, the things we're trying to protect, the actions we're trying to perform, are delivered back to the person or entity we think they are intended for?
So it's not just about keeping bad actors out.
No, it's also about ensuring the system works correctly for legitimate users. It's about establishing fundamental operational reliability. If the system can't definitively trust the identity at each step, then the entire chain of actions it takes and the data it provides back becomes inherently untrustworthy. You can't rely on the outcome. This is really the essence of the trust problem in these new AI-driven systems. We're delegating more and more autonomy to AI. So our trust in the underlying identity mechanisms has to be absolutely rock solid.
It's clear that the traditional models, simple delegation, they start to buckle under the weight of all this agentic complexity. Let's introduce another delegation pattern that tries to address some of this, called on behalf of delegation. This sounds like an agent is explicitly acting as a kind of proxy for the user.
That's a very precise way to put it, yeah. On behalf of delegation, we move to a model where both the user and the agent possess their own distinct identities. They each have their own tokens, their own associated privileges.
Okay, two identities involved.
Two identities. The agent is explicitly authorized by the user to act on behalf of them. The user, at the beginning of the interaction, explicitly trusts that specific agent to perform actions within a certain authorized scope.
Can you give an example?
Sure. If a user wants to book a flight, they might delegate authority to a travel agent, AI. This AI then uses its own identity, combined with the user's delegated authority token, to interact with airline systems, hotel booking platforms, maybe car rental services.
And the benefit is clearer tracking.
Exactly. The beauty here is that audit logs would clearly show both the user's initial request and the specific agent's actions performed on their behalf. It provides much clearer attribution. The user wanted it done, and you know which agent actually did the work.
So it provides a clearer attribution model. We know the user and the specific agent involved. But it sounds like this also introduces maybe a new layer of complexity, especially when these agentic environments get highly dynamic, like you described.
It absolutely does. That's the catch. The new problem really arises when agentic flows become highly dynamic, which is kind of the point of many sophisticated AI systems. What happens when multiple agents, maybe even new agents, or perhaps ephemeral agents that only exist for a short time, get introduced or swapped out within a single user request?
Right, the self-driving taxis taking detours or calling other taxis.
Exactly. How can the user establish and maintain trust with all these different, maybe transient agents, especially agents they didn't explicitly choose at the start or maybe don't even know exist deep within the system?
Yeah, if my trusted travel agent, AI, suddenly spins up a sub-agent to handle a specific hotel booking.
Right. And maybe that sub-agent then calls another third-party agent to check loyalty program points.
Yeah.
How do I, as the user who started the whole thing, know I can trust that entire chain of delegation? This dynamic, often opaque nature makes it incredibly challenging to maintain explicit individual trust relationships for every single step, every single agent involved.
And that leads us directly to what the experts are calling the transitive trust conundrum. This sounds like an even higher level challenge, moving beyond just trusting individual agents to trust in the whole system.
It truly is an elevated challenge, and it's perhaps the most significant conceptual shift we need to make when thinking about security in these complex, dynamic AI environments. The core idea is that the user cannot realistically be expected to individually verify and trust every single agent in the system.
Just not practical.
Not at all, especially when those agents might be spun up on the fly, they might be transient, they might be part of a vast interconnected network, maybe spanning multiple organizations. Imagine trying to personally vet every single person who handles your package when you order something online. The warehouse picker, the truck driver, the sorting facility worker, the delivery person.
You just trust the shipping company.
Exactly. You trust the system, the brand, the process. It's simply not feasible for a human to verify every step, and it's equally impractical in a highly distributed digital system with potentially hundreds of agent interactions per request.
So this implies a fundamental paradigm shift in how we have to approach trust. It's no longer just about trusting individual components or the very next hop in the chain.
Precisely. Instead, the user, implicitly or explicitly, must place their trust in the entire system to act securely and reliably on their behalf. They're delegating their authority and essentially trusting that the overarching framework, the architecture, the security measures governing all those interconnected AI agents, that it will ensure every subagent and process behaves as expected and upholds the initial trust established.
That's a big leap of faith.
It is. It represents a significant shift from component-level trust, I trust agent 1, to a much broader systemic level of trust. I trust this whole platform to manage its agents correctly. And that, of course, requires incredibly robust underlying mechanisms, strong governance, continuous monitoring, and detailed auditing to make it actually work and be worthy of that trust. It's a huge ask for users, maybe, but it's an absolute necessity if these powerful systems are going to scale and be adopted responsibly.
Okay, and just to make things even more complex, we live in a world of large enterprises. And those enterprises, they rarely operate as a single monolithic entity, do they?
Not at all.
They have different divisions, maybe they've gone through mergers, they have external partnerships. This brings us to the challenge of navigating multiple identity providers, multiple IDPs, and crossing organizational boundaries.
Yeah, this is where the theoretical complexity really hits the practical, messy reality of the real world. Modern enterprises were almost never monolithic. They often consist of various divisions, different business units, each potentially with its own legacy systems, its own data silos, and crucially for our discussion, its own identity management infrastructure, its own IDP.
Right. Different departments might use different systems.
Exactly. And even more commonly, enterprises frequently need to interact securely with external organizations. Think of Company A needing to collaborate with Company B on a joint project, or maybe a customer using their own corporate login credentials to access a service provided by a third-party vendor. Each of these entities, Company A, Company B, the vendor likely maintains its own independent identity provider.
So different ways of logging in, different identity systems.
Different authentication methods, potentially different ways they store identity information, schemas, and different trust policies and security postures.
So an agentic flow might not just stay neatly within one company's digital walls or under the control of one IDP. It might have to actually jump across these boundaries, like crossing digital borders.
Precisely. You could easily imagine an agentic flow that starts inside Company A. Maybe it's initiated by an employee using Company A's internal IDP, but then that flow might need to access data or invoke a service hosted by Company B, which uses its own completely distinct IDP.
How does that even work?
Well, the flow might even involve some kind of intermediate router agent or a specific integration agent whose job it is to figure out how to securely pass the agentic request and, crucially, the user's identity across these different organizational trust domains. This necessitates seamless interaction, secure translation of identity information, and continuous verification of identity and privileges between these disparate identity management systems. The protocols and the assertions or tokens from Company A's IDP need to be somehow understood and trusted by the systems connected to Company B's IDP.
And what's the added layer of complexity here, beyond just the technical challenge of making the pipes connect?
It significantly complicates how identities and their associated privileges are translated, verified, and remain secure when moving between these independently managed, potentially very diverse identity infrastructures. It's not just about passing a token anymore.
No.
It's about ensuring that a token issued by Company A's IDP is understood, validated, and trusted by Company B's systems. It's about ensuring that the scope of permissions granted by Company A remains appropriate and secure when interpreted and enforced by Company B. And it's about ensuring that auditing can still somehow track the original user's action all the way through.
That sounds like it needs specific agreements and standards.
Absolutely. This often requires establishing quite elaborate federation agreements between the organizations and leveraging advanced identity standards specifically designed for this, like SAML 2.0 Federation or OpenID Connect Federation. These provide frameworks for managing these interorganizational trust relationships. It's a critical challenge and one that current solutions are actively trying to address and simplify because it's absolutely fundamental to how businesses will collaborate and interact in an increasingly AI-driven world.
Okay, so we've outlined the foundations and, more importantly, the really profound new challenges that AI agentic systems throw at us. From impersonation risks, like our friend Edwina Cutwater, to the deep problem of transitive trust, especially across dynamic systems and organizational boundaries. Now, let's pivot. Let's turn our attention to the strategies. What's emerging to forge trust and build security in these complex environments? And as you said, it's important to remember, this is an emerging space.
Right. Solutions are still evolving. Things are moving fast.
But these strategies represent the current best thinking, the best practices people are implementing now.
Indeed. The solutions we're about to discuss are what forward-thinking organizations are actively implementing right now to try and navigate these complexities, moving beyond those traditional models that, as we've seen, just aren't really sufficient anymore for this new world.
Right. The first strategy, and you could argue it's the most fundamental one, is embracing industry standards. Specifically, you mentioned OAuth 2 and OpenID Connect, or OIDC. This sounds like the absolute bedrock, the foundation everything else needs to be built on.
It truly is the bedrock strategy. The recommendation here, loud and clear from experts, is to consistently and rigorously adhere to these established industry standards for identity and access management. OAuth 2 provides a robust framework for secure delegation of access.
What does that mean, delegation of access?
It's fundamentally about granting limited access to resources like specific data or API functions without having to share the user's actual credentials, like their password. OpenID Connect, or OIDC, then builds right on top of OAuth 2 to provide the identity verification layer. It effectively tells you who the user is, in addition to OAuth telling you what they can access.
Okay, so OAuth is the permission slip mechanism, and OIDC verifies the name on the passport.
That's a great way to put it. OAuth 2 for the secure permission slip, access delegation, and OIDC for securely verifying the identity on the digital passport, authentication.
Why do these standards matter so much in this new context? With dynamic AI agents, especially when you think about multiple organizations needing to talk to each other.
Because together they create a robust, agreed-upon framework. Essentially, a common language for how users are identified and what their rights and privileges are. This is incredibly powerful. It establishes a common base for secure communication, which vastly simplifies secure interactions between different systems.
Especially across those company boundaries.
Absolutely crucial when crossing organizational boundaries, where different entities, maybe with their own IDPs, need to interoperate securely. If Company A and Company B both operate based on these well-defined industry standards,
It makes things much easier.
it makes secure identity propagation across their systems significantly easier, more reliable, and more standardized. Without these standards, every single inter-system interaction would require a custom, likely complex, and often less secure bespoke integration. OAuth and OIDC provide the necessary interoperability and the shared trust framework needed for a distributed, multi-party digital ecosystem.
It's like agreeing on using USB ports instead of everyone inventing their own connector.
Exactly. It's the reason you can, log into a third-party app using your Google or Facebook account. That's OIDC and OAuth in action. Now we're just scaling that concept up for potentially complex, automated, enterprise-level agent interactions.
That makes perfect sense. Establish that universal language for identity first. Now, this next strategy sounds like a real game changer, specifically for these agentic flows. Implementing token exchange at each node. This idea of re-verification feels critical for those multi-hop journeys we talked about.
Yes, this is indeed a critical innovation, maybe one of the most important practical strategies for agentic systems. It directly addresses that blind trust problem we discussed, where an agent just trusts the identity passed from the previous hop.
So instead of just passing the original token along.
Right. Instead of just forwarding the initial token that the user got at the very beginning of the flow, the core concept here is to exchange that token at every single hop or node within the agentic flow.
Every single one.
Every single significant hop. It's almost like needing a new specific visa stamped in your digital passport every time you cross an internal border within the overall system.
So it's not just a pass-through. It's like getting a fresh, context-specific credential reissued at each step. How does that actually work in practice, say, between Agent 1 and Agent 2 in our earlier example?
That's exactly right. At each step, the current agent, let's say Agent 1, doesn't just hand over the token it received representing the user. Instead, Agent 1 acts as a client. It goes back to the identity provider or potentially a trusted, dedicated token service that's authorized by the IDP to issue tokens, and it exchanges the existing token for a brand new one.
A new token specifically for Agent 2.
Precisely.
Yeah.
This new token is specifically tailored, specifically scoped and audienced for the next intended hop in the flow, which is Agent 2. This typically uses a specific OAuth 2.0 grant type, often referred to by its technical name, earn.ietf.params.o.grant-type.token-exchange. It's a standard designed exactly for this scenario. It allows one party, Agent 1, to securely exchange one security token, like the user's initial token, for another security token, a new specific token intended only for Agent 2, based on its authorization to do so.
Okay, that sounds powerful. So what's the primary benefit of doing this constant exchange and revalidation? And how does this directly help combat that chilling impersonation scenario? Edwina Cutwater injecting a false identity for Roger Cobb.
Okay, the primary benefit is continuous explicit validation at each step, and also a significantly reduced blast radius if something goes wrong. This constant re-exchange and revalidation ensures that the user's identity is continuously verified and reasserted at every stage. It dramatically reduces the risk of a compromised or invalid identity being blindly propagated through the system.
And the impersonation angle.
Right, to address impersonation directly. Remember our bad actor, Edwina, injecting a false identity for Roger? With token exchange properly implemented, the system has a predefined understanding of its legitimate agentic flows and the known trusted endpoints involved.
It knows what the path should look like.
Exactly. So if an injected unauthorized agent like Edwina attempts to pass an impersonated identity, it would likely present a token that either isn't valid in the first place or, crucially, when it tries to exchange that token at the next legitimate hop.
The exchange fails.
The identity provider, or the token service, knowing the legitimate path and the expected relationships between agents, would detect that this is an unauthorized exchange request. It would see that the token's origin or its current context doesn't match the expected flow configuration. It might see that the agent trying to make the exchange isn't authorized to act on behalf of the identity in the token, or isn't the expected previous step, and the exchange would be rejected. The imposter is stopped cold.
So it's like a highly vigilant Border Patrol agent at every single internal checkpoint.
Yeah.
They're not just looking at the passport. They're checking the visa, making sure it's specifically for this next leg of the journey, and confirming it matches the expected itinerary. Anything suspicious gets rejected.
That's a fantastic analogy, yes. This strategy rigorously verifies identity and establishes trust throughout the entire multi-hop flow. And the beauty is, it can even extend its effectiveness across company boundaries.
Really? How?
If Company A and Company B have established mutual trust for token exchange, and their respective IDPs are configured appropriately using federation standards to understand and validate each other's tokens, you can maintain this continuous validation even when the agentic flow traverses between the organizations.
Wow.
It's a powerful mechanism for building robust, auditable trust in these highly dynamic, distributed AI systems. But it's fair to say it does come with some overhead. Well, you're making more network calls back to the IDP or token service at each hop. That adds latency and puts more load on your identity infrastructure. So organizations definitely need to design their systems to handle that load efficiently.
Okay, so token exchange provides much higher security and granular control at each step. And it sounds like it leads us directly into the next strategy, which is about leveraging context, scope, and audience for even finer-grained control. This sounds like getting incredibly specific about what exactly a token allows and where it's allowed.
That's precisely what it is, and this is where the real power and, frankly, the elegance of modern identity standards like OAuth 2 and OIDC really come into play. This strategy uses features built into these standards, features that are sometimes underutilized, to provide highly granular control over what an agent is permitted to do, and crucially, when it can do it, and for whom or which specific service it can do it.
It's like having your digital passport specify not just your name, but exactly which doors you can open, and maybe only for a specific purpose, and only during certain hours.
That's a perfect way to think about it. Context sort of refers to the overall situation or environment of the transaction. But scope and audience are especially critical here for limiting potential damage and ensuring correct routing. Let's start with scope. How do we apply that effectively in an agentic flow?
Okay, scope.
Scope is absolutely crucial for the authorization part. What are you allowed to do? The key principle here, and this is a big shift from older models, is that instead of granting broad, maybe enterprise-wide, access permissions at the very beginning of a flow.
Which sounds risky.
Very risky. Instead, the scope, which defines what the user or the agent acting on their behalf is authorized to do, should be progressively narrowed down at each successive node or hop in the agentic flow.
Narrowed down. How?
Think of it like this. A user might have a relatively broader scope when they first authenticate with the system. Maybe they can initiate various types of requests or view general customer data. But by the time an agent deep in the flow needs to access something really specific and sensitive, let's say, it needs to update a customer's payment information in a database.
Right, high-risk action.
High risk. The token exchange for that specific agent should have its scope made very narrow. It might only allow that precise database interact, say, the update payment info function, maybe only for that specific customer record. Or the scope might literally be just payment.write, nothing more.
So if that highly limited token somehow gets compromised or leaks downstream, the potential damage is drastically minimized. Because it can't really do much beyond its one specific narrow task. It's not a master key.
Precisely. You've hit the nail on the head. It minimizes the blast radius of any potential compromise. If a token with a broad scope, like admin or user, gets stolen, a bad actor can wreak havoc. But if a token with a very narrow scope, like report.read.q3 financials, gets stolen, well, the damage is contained to just reading that one report.
Makes sense. Least privilege at every step.
Exactly. Principle of least privilege applied dynamically throughout the flow. The other critical feature you mentioned is audience.
Audience, what's that?
This allows a token, particularly the exchange token, to explicitly specify its intended audience. The audience is the next specific recipient or agent that is authorized to accept and process that token. It's basically a way of saying, this token is explicitly intended for Agent X and absolutely no one else.
Like addressing a letter to a specific person.
Exactly like that. So how does audience verification powerfully prevent those unauthorized injections and make sure the right agent gets the right token for the right job?
Okay, when an agent receives an exchange token, say, Agent 2 receives the token exchanged by Agent 1, it performs a crucial validation check as part of processing that token. It verifies if it is indeed listed as the intended audience, often represented by a claim like odd in a JWT. This is a standard, mandatory validation step in secure token processing.
And if it's not the intended audience?
If the agent checking the token finds that it is not the intended audience specified within the token, or maybe the audience value is missing or incorrect, the token is immediately rejected, flat out.
Ah, I see. This powerfully prevents unauthorized injections with impersonated identities. Our rogue agent, Edwina, trying to insert itself into the flow, it would likely present a token where the next legitimate agent in the chain is not the designated audience. So when that legitimate agent receives the token, it checks the audience, sees it's not meant for it or it's meant for the imposter, and boom, reject it.
So the combination is key.
Yes. These combined features, context, progressively narrowed scope, and strictly defined audience create a much more secure and resilient identity propagation mechanism within these dynamic AI agentic systems. They enforce least privilege and correct routing at every single step.
This level of detail, this fine-grained control with token exchange, scope narrowing, audience checking, it sounds incredibly powerful, but it also sounds like it could be a lot for individual developers to manage correctly within their own agent code for every single interaction. Is there a way to maybe centralize and simplify this complexity, make it more manageable at an organizational scale?
Absolutely there is. And that brings us very neatly to our next crucial strategy, leveraging API gateways. The strong recommendation from many experts is to connect the various nodes and agents within the agentic flow, especially when they cross service boundaries or departmental lines using API gateways.
API gateways, why them? What makes API gateways particularly suited for this central role in managing identity and trust in these complex agentic systems?
Well, first off, organizations are generally already highly familiar with APIs. REST APIs, the whole concept of API economies, it's well understood. API gateways act as central enforcement points or choke points for API traffic.
Like a security checkpoint at the entrance to a building.
Exactly. They sit between the requesting agent, the client, and the target service or agent, the backend. They control traffic, they can apply security policies, perform logging, handle transformations, and crucially perform various security checks before a request ever reaches the backend service or agent. They can handle things like authentication, authorization, rate limiting, routing.
Okay, and how do they specifically help with that complex token exchange process you just described and validating the scope and audience?
This is where their value really shines in this context. Crucially, the API gateway can be assigned the responsibility of performing that complex token exchange mechanism we just discussed.
The gateway does the exchange, not the individual agents.
Correct. Instead of each individual agent having to implement the logic for going back to the IDP, exchanging the incoming token, validating it, and then creating a new, narrowly scoped token for the downstream service. The gateway can handle much of that automatically, often almost transparently to the agents involved.
How does that work?
The gateway receives the request from Agent 1, validates the incoming token, including audience and scope. Then the gateway itself interacts with the IDP or token service to exchange that token for a new one, specifically scoped and audienced for the intended downstream agent, Agent 2. It then forwards the request to Agent 2 with this new appropriate token.
So it offloads a huge amount of complexity from the developers building the agents.
A significant burden, yes. They no longer need to become experts in the intricate details of oath token exchange protocols or the nuances of JWT validation, scope mapping, and audience checking within their own agent code. They just need to know how to securely call the API gateway and how to receive and maybe validate the token the gateway provides for them. The gateway ensures that the downstream agent receives a valid, appropriately scoped token for its specific interaction.
So it centralizes control, which is good for security consistency.
Yeah.
It makes developers' lives easier by abstracting away that complexity, and it standardizes security practices across the organization. That sounds like a huge operational win.
It really is. This centralizes and standardizes how token exchanges and initial validation are performed across an entire organization, or at least large parts of it. It leads to far greater consistency in applying security policies. It improves overall system security by reducing the potential for individual developers making subtle, hard-to-find coding errors in complex security logic. And as you said, it significantly boosts developer efficiency. It lets them focus on the core business logic, the smarts of their AI agents, rather than getting bogged down in the intricate plumbing of identity management. It becomes the central point for enforcing all those passport and visa checks across all the agentic interactions passing through it.
Okay, all these strategies relying on industry standards, doing continuous token exchange, using fine-grained scope and audience control, centralizing operations with API gateways. These are all about building security in from the ground up, architecturally designing for trust. But even with the best architecture, the best fences and gates, you always need a watchful eye, right? An active monitoring system. This brings us to what sounds like the final, maybe non-negotiable strategy, continuous monitoring.
That's exactly right. Implementing robust, ongoing monitoring across the entire agentic flow is not optional. In these kinds of dynamic systems, it's absolutely essential. You could think of it as the operational nervous system for these complex, sometimes unpredictable environments.
What's the primary purpose? What exactly are we looking for when we continuously monitor these dynamic AI agent systems? What signals are important?
The primary goal is really multifaceted. First, it's to ensure compliance, making sure the system is adhering to the security policies you've set. Second, it's about maintaining the integrity of the system, detecting any signs of compromise or malfunction. And third, critically, it's about verifying that identity propagation is behaving precisely as intended at all times.
And why is continuous monitoring so vital here, maybe more so than in older, more static systems?
Because in dynamic AI systems, agents can interact in potentially unpredictable ways. New agents might be introduced, maybe configurations change, perhaps agents even self-modify their behavior based on learning. Continuous monitoring is vital for promptly detecting any anomalies that might arise from this dynamism.
What kind of anomalies are we talking about?
Things like unauthorized access attempts, maybe a token being used outside its permitted scope, or being presented to an agent that isn't its designated audience. We're looking for signs of privilege escalation attempts. We're looking for unusual data access patterns. Why is this agent suddenly trying to read way more data than usual? Or any significant deviations from expected agent behavior that might indicate a compromised identity, a stolen token, or maybe a malicious insertion into the flow that somehow got past the other defenses.
So it's not just about setting up the fences initially, like the token exchange and gateways. It's also about actively patrolling the perimeter and maybe even the interior, constantly looking for anything unusual. How does this fit into the broader picture of establishing trust?
It's the essential feedback loop. Monitoring is how you actually validate whether your carefully designed architectural strategies and security policies are actually working effectively out there in the real messy world. You need comprehensive logging from all the agents, the gateways, the IDP, and you need real-time alerting systems built on top of that.
So you know immediately if something's wrong.
Right. If a token exchange fails unexpectedly multiple times, if an agent consistently tries to access data it shouldn't, if there's a sudden, unusual spike in requests associated with a particular identity or coming from a strange location, the monitoring system must immediately flag it for investigation. It's an ongoing operational requirement, not a one-time setup task. It's the eyes and ears that constantly validate whether the implemented strategies are working as designed and, crucially, alert you the moment they might not be, allowing for rapid response and remediation before major damage occurs. This constant vigilance is what truly builds and, more importantly, maintains long-term trust in these highly autonomous systems.
Wow. Okay, so we've really taken a deep dive into what is clearly one of the most critical, maybe even foundational challenges facing organizations as they race to embrace the transformative power of AI agentic systems.
It's definitely up there.
We started by getting a handle on the foundational patterns of identity propagation, no delegation, trusted assertion, simple delegation. Then we really dug into the profound new complexities introduced by these multi-hop dynamic agentic flows. Everything from the very real peril of impersonation by bad actors below Edwina Cutwater
Right.
to that deep, almost philosophical problem of transitive trust.
Yeah.
How do you trust a whole system when you can't verify every single step, especially when crossing organizational boundaries with multiple IDPs?
And then, importantly, we outlined that set of emerging but really robust strategies that leading organizations are employing right now to try and forge and maintain trust in these new kinds of systems.
Right. We talked about embracing those established industry standards, OAuth 2 and OpenID Connect, getting everyone speaking the same identity language.
This foundation.
Implementing continuous token exchange at each node, that rigorous re-verification to stop impersonation and maintain context.
The constant visa check.
Leveraging that fine-grained control through progressively narrowed scope and strictly defined audience least privilege all the way down the chain.
Minimizing that blast radius.
Centralizing the complex identity operations, like token exchange, using API gateways to simplify things for developers and ensure consistency.
Making it manageable and scalable.
And finally, underpinning it all, the absolute necessity of maintaining that vigilant eye through continuous real-time monitoring.
The essential feedback loop. You need all those pieces working together.
It seems crystal clear that as organizations continue to rapidly adopt these truly transformative AI technologies, understanding and diligently implementing these kinds of robust security measures for identity and trust isn't just a nice to have, it's going to be absolutely paramount.
Paramount for ensuring their success, for maintaining data integrity, for meeting compliance requirements, and ultimately for building and maintaining public and customer trust. This isn't just, technical plumbing in the background. It's rapidly becoming the very foundation upon which secure, reliable, and accountable AI systems must be built.
Absolutely. The stakes are just incredibly high. And while, as you said, the solutions are still evolving, these strategies offer a clear, actionable path forward for securing these increasingly complex and autonomous systems. It really feels like a journey of continuous learning and adaptation for everyone involved.
It definitely is. The technology is moving fast, and the security practices need to keep pace.
It leaves me with a final, maybe more provocative thought for you, our listener, to mull over. As these AI systems become not just tools that we use, but increasingly autonomous agents making decisions, taking actions, and interacting on our behalf, how might our very definition of digital identity itself start to evolve?
That's a deep question. Does an agent acting on my behalf share part of my identity, or does it have its own that's just linked to mine?
Right. And what new ethical responsibilities start to fall upon us, both as individuals and as organizations, as we delegate more and more significant trust and agency to these complex, interconnected AI systems?
That's a profound thought. The traditional boundaries of identity, agency, responsibility, they're certainly getting blurry in this new world where an AI agent can act on your behalf in really quite nuanced ways. It really does make you wonder about the very nature of agency and identity in an increasingly digital, automated world.
We've really only just scratched the surface of this fascinating and incredibly critical topic today. There's so much more we could discuss, and we genuinely love to hear your thoughts, perhaps your questions, or maybe even your own experiences grappling with managing identity in complex digital environments. How do you envision identity management continuing to evolve in this AI-first world we're heading into? We encourage you to share your perspectives and insights with us. Your contributions truly enrich this deep dive for everyone in the community.
Yeah, hearing different viewpoints is always valuable in such a fast-moving field.
And if you found this deep dive valuable, if it gave you some things to think about, we'd appreciate it if you'd subscribe to the deep dive so you can catch all our future explorations into critical topics like this. Maybe share this deep dive with colleagues or friends who you think might benefit from these crucial insights into the future of AI security and trust. Your support really helps us continue to bring more well-informed content like this to you. Thanks for joining us.